Today we are going to talk about writing the equations for ellipses. By the end of this video, you should be able to write the equation of an ellipse in standard form. Just a reminder, from our last video, we have two types of ellipses, a horizontal ellipse and a vertical ellipse. The equation for a horizontal ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. And the equation for a vertical ellipse is x minus h squared over b squared plus y minus k squared over a squared equals 1. And in both of these situations, a is always greater than b. When we are trying to write our equations, we need three pieces of information. We need the center, which will give us hk, and we need to know what a and b are. Once we have those three pieces of information, we can write our equation. For our first example, we want to write the equation of an ellipse that has a focus at 0, 2 and vertices at 0, -3 and 0, 3. So let's sketch what we have. We know that one focus is at 0, 2, and we know that the vertices are at 0, -3 and 0, +3. Since these 3 points form a vertical line, we know that this is going to be a vertical ellipse. We know that the center is halfway between the vertices, which means that our center is going to be 0, 0. Then we need to find what a and b are. We know that the distance from the center to the vertex is a. So by looking at the graph, we can tell that a will be 3. The distance from the center to the focus is c, which in this case is 2. And we can use this to figure out what b is. Since we know that c is the square root of a squared minus b squared, we can just plug in our numbers and solve. So if we plug in 2 equals square root of 9 minus b squared, we square both sides to get rid of the square root. We have 4 equals 9 minus b squared, and we end up with b squared equals 5. Now, we could continue to solve and figure out that b is the square root of 5, but since we end up squaring b in the equation, I'm just going to leave it at b squared. So, when we plug this back into the equation, we know that our center is 0, 0. So we know that we have x squared and y squared as our numerators. Since it's a vertical ellipse, we know that a squared needs to be the denominator of the y fraction, and b squared should be the denominator of the x fraction. And that is our equation. Next, let's write the equation of the ellipse with a center at 2, -3, one focus at 3, -3, and one vertex at 5, -3. So we are told what the center is. That's 2, -3. We know that one focus is at 3, -3, and we know that one of the vertices is at 5, -3. Since these 3 points form a horizontal line, we know that this will be a horizontal ellipse. We know that the center is 2, -3. Now we need to figure out what a and b are. We know that a is the distance from the center to the vertex, which is 3. we know that C is the distance from the center to the focus, which is 1. And similar to the last problem, we can go ahead and solve to see what B will be. So we have C equals square root of A squared minus B squared. So when we plug our numbers in, we have 1 equals square root of 9 minus B squared. Square both sides and solve for B squared. We get that B squared is 8. So when we plug this in, we have x minus 2 squared and y plus 3 squared as our numerators. Since this is a horizontal ellipse, a squared is the denominator of the x fraction, and b squared is the denominator of the y fraction. And that is our equation. Lastly, let's look at one word problem. There is a hall that has been designed to be a whispering chamber. The hall is 50 feet wide, and the elliptical ceiling begins 6 feet above the floor and extends 20 feet high at its center. Where are the foci located in this hall? So, to make our lives a little bit easier, let's ignore the fact that the ceiling or the ellipse starts 6 feet above the floor. We'll deal with that at the end. We know that it's 50 feet wide, and we know that it's 20 feet high. Well, clearly our graph does not go to 50 or 20, so let's say that each one of these lines is going to be 5. So I'm going to say that our scale is that one line is 5. So we know that the elliptical ceiling is 20 feet high in the center, which would be 4 on our scaled graph. And we know that the hall is 50 feet wide. So that will be our major axis, which means that from this center of 0, 0, we're going to go 25 feet or 5 units in either direction. So we have set that the center is at 0, 0. We need to find out where our foci are. So we can see that these 2 points are our vertices. We know that A is the distance from the center to the vertex, which in this case will be 25 feet. And this point that represents the peak of the ceiling is our covertex. So we know that B is the distance from the center to the covertex, which in this case is 20 feet. To find the foci, we need to know what C is. So C is the square root of A squared minus B squared. So we have square root of 25 squared minus 20 squared. So we get that C is 15. So that means that our foci would be here and here. So since this is a word problem, we need to make sure that we write our answers in words. So our foci are 15 feet from the center, but they are not on the floor. They are going to be 6 feet above the ground where the ellipse starts. So the foci are 15 feet right and left from the center and 6 feet above the ground. So in a whispering chamber, this means that if people were standing at those points, that they would be able to whisper and the sound would carry so that they would hear each other perfectly if they are standing one at each focus. The 6 feet above the ground part means that someone who is approximately 6 feet tall, their head would be about where the focus is, and that they would be able to whisper to somebody standing on the other focus.